In this video, we will explore the non-inverting amplifier. In the last video, we talked about the inverting amplifier, in which we keep the op-amp in negative feedback and apply an input towards the inverting terminal. Now, we'll take a look at the opposite case. Let's see what happens when we apply our input to the non-inverting input terminal. We'll ground the node at which we placed our input in the previous case. We'll apply an input Vin to the non-inverting terminal. We want to find a relationship between Vin and Vout. Let the voltage at the inverting input be Vx. No current flows through the inputs of the op-amp. Hence R1 and R2 form a resistor divider. That means, a fraction of the output is fed back to the inverting input. By simple voltage division, the voltage at node Vx will be R1 upon R1 plus R2 into Vout. Since the op-amp is in negative feedback, the virtual short condition is valid. Hence, the voltage Vx at the inverting input is same as the voltage Vin at the non-inverting input terminal. Equating these two, we get Vin is equal to R1 upon R1 plus R2 into Vout. A little rearrangement gives us Vout upon Vin is equal to 1 plus R2 upon R1. Hence, we've created an amplifier with a gain of 1 plus R2 by R1. We can control the value of gain by adjusting R1 and R2. As this is a positive quantity, the output is in phase with the input. Hence, it is called a non-inverting amplifier. For example, if we choose the value of R1 as 1 kilo ohm and R2 as 2 kilo ohms, then the value of the gain will be 3. So, if we feed a sinusoid to the input of this circuit, we will get a sinusoid with thrice the magnitude, which is in phase with the input. In this way, we achieve amplification with an op-amp. Now, let's consider the case of a practical op-amp with an open loop gain of A. No current flows through the input of the op-amp, which means that R1 and R2 form a resistor divider. By voltage division, the voltage in node X will be R1 upon R1 plus R2 into Vout. By the basic amplifying action of the op-amp, Vout will be the open loop gain A into the differential input voltage, which is Vin minus Vx. Substituting the value of Vx we found just now, we get the following equation. This is the equation of the gain of a practical non-inverting amplifier. Suppose A is a very high value. 1 upon A will be a very small value and can be neglected. A little rearranging gives us 1 plus R2 by R1, which is the gain we found in the ideal case. Hence, for op-amps with high values of gain, we assume them to be ideal. This finishes the analysis of the non-inverting amplifier. That's it for this video. If you have any doubts, please ask in the comments section. Don't forget to like, share, and subscribe.